Is on sequences and series. AP pre-calculus, do you guys do sequences and series in that course? Okay. Regular pre-calculus we did, because I did it for you, or with you guys. So potentially this will be a bit of a review. I'll let you hold on a second. I have some papers for you.
Thanks.
You just,
Thanks.
you're welcome. Okay. So, just as a teensy bit of vocab review, so you guys remember what a function is? We talked about it last chapter. So a function is just like a map that sends some input, some x in our domain, to some output, some f of x in our range. So our interval notation would be like f of x equals 2x plus 5, where the x is like our independent piece, and the 2x plus 5 would be like our dependent piece. A sequence can be thought of quite similarly, except that for a sequence, the domain is going to be the natural numbers. What are the natural numbers again? The counting numbers. Usually we start with 0, 1, 2, 3, but kind of depends on the course. In some contexts, the natural numbers will include 0, and sometimes it won't include 0, because why would we do anything consistent, right? So a sequence is a special type of function where the domain is always going to be the natural numbers, and the range can be any subset of the real numbers. So you can get decimals and stuff as your outputs, that's fine, or irrational numbers or whatever. So instead of using an f of x notation, we use like an f and then like a subscript n. So typically when we talk about a sequence, we use the lowercase letter n as our standard variable. We call that independent variable the term number. And then the output of that sequence would be like the term value. Okay, so we're just kind of talking through some notation and some vocabulary right now, so that when we start talking about these things in earnest, it'll be easier to communicate, because we'll have a common language. So for example, if we say that f subscript 5 is equal to 18, the way you read that is that the fifth term in the sequence is 18. Right? The subscript is telling you the term number, that's why it's the fifth. And the term, the actual term value, that fifth term is 18. Bless you. Is everybody okay with the verbiage there that we're using? AP pre-calculus, is this looking familiar? Like something we might have done? Okay. So let's just look at a couple of examples here. So if I have my value for n, we're going to consider the first, second, third, fourth, and fifth terms. So I could describe a sequence f as the value of those first 5 terms. So 1, 4, 9, 16, 25, and notice that it stops there. We'd call that a finite sequence because there's an end to it. Now, if we look at the sequence below it, sequence G, what's the only difference between F and G? Is there's that ellipsis at the end, the dot, 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 indicating that G is going to continue going on in that pattern forever. We call G an infinite sequence. Everybody feel okay there? Does anybody see the pattern of what's going on between in this sequence G?
Square root of
N squared, yeah. Yeah, it's the term number squared would be the term value. So 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, etc. So for example, if I asked you to give me the first 5 terms of the sequence, b sub n is equal to 2 minus 1 over n. Well, to write the first term, I'd write b subscript 1. And what would I do? Just plug 1 in for n, and then I evaluate, right? So the first term is 1. The second term would be like 3/2, so you could write 1.5 would be fine. Yeah. The third term would be like 5/3. Like 7/4. And then like 9/5. And again, if you wanted to write those as decimals, you could write those as decimals, that's fine. I prefer fractions because it's a little bit easier to write it on the board computationally. Does everybody feel okay as to how I generated terms from an explicit formula of a sequence? Right. That should be relatively easy. Now we can use one of these sequences to like model some real world behavior. So this says a 180 liter bathtub contains 50 liters of water and is being filled at a rate of 10 liters per minute. How much water is in the tub after 5 minutes? So if I wanted to write this as a sequence, we start out with how much initially? How much water? 50, right? And then each minute we're going to pick up 10 liters, right? So if I want how much is in the bathtub after 5 minutes, I can just plug 5 in for my n, and bada boom, bada bing, I got 100 liters. When will the water overflow the tub? How much water can the tub contain? 180. So I would plug in 180 for my term value. And then I'm going to be solving for n, the term number, which is the same thing as the number of minutes. So when I do that, I get n equals 13. So how would I answer this? Be a little bit careful here on how you're phrasing this. Nope. At 13 minutes, how much water will be in the tub? 180, right? Will the tub be overflowed if there's 180 in it? No. 14 is, well, what happens between 13 and 14? Is the tub overflowing though? So starting at 14 is wrong also. What do you want to say? How about we just say after 13 minutes? about that? How's that sound? Just use some English language there. The point which the tub is full is at 13, so any time after 13, that's overflowing. Okay. It says now the drain has been opened when the tub contains that 50 liters of water. Also, it's draining out at a rate of 15 liters per minute. How long to empty the tub? So in addition to 10 coming in, we have 15 going out. So we'll use a subtraction there. When will the tub be empty? Well, when there's 0 water in it. Solve, it looks like about 10 minutes. Does everybody feel okay here? The algebra happening should be very simple, right? Just doing like pre-algebra level, two-step equation solving, very straightforward. What we're going to do next is we're going to talk about 2 special kinds of sequences. Notice that I haven't asked you to write the equation or the explicit form for any of these sequences we've been talking about. Right? We've just been kind of talking about sequences in general. We're going to talk about 2 specific types of sequences today. One is the arithmetic and the other is the geometric. We're going to talk about the arithmetic sequence first. And the way you want to scaffold this onto your previous learning is that when you hear arithmetic sequence, you want to think linear function. Okay? Everything all the techniques you know how to do to build an equation for a line or to solve an equation, a linear equation, all still valid for arithmetic sequences. So we're going to start off by giving us 2 formulas. The first is the formula to write the explicit equation for the arithmetic sequence, and the second is to write the recursive. So when we say explicit, that means that the formula is only based on the term number. So if I ask you for the 50th term, you can go straight to the 50th term. The recursive formula is a formula that's based on some previous term. So in this case, it would be the term before. So if I wanted the 50th term, and I'm using the recursive sequence formula, I would have needed the 49th term in order to get that, right? Now, recursive formulas tend to be easier to write, but they're a little bit of a hassle to deal with because if I want the 10,000th term, I probably have to calculate the 9,999 terms beforehand in order to get that. Now, me doing that by hand stinks, but you know who's really good at repeated calculations? Computers, right? Your calculator. So like the recursive formula can be really nice because it's easy to write the formula and the computer handles it oh so well without even breaking a sweat. The explicit formula tends to be a little harder to develop, but much more practical to use for a human being. So there are 3 terms in here that we should be cognizant of. So the a sub n and the n is like the x and the y in our equation for a line, right? A sub 1 is the value of the first term in the sequence. A sub n minus 1 just means the previous term. We'll do an example where we compute some terms using a recursive formula. So you get a feel for that. And then that leaves us the D. The D is the common difference. So in the terms of a arithmetic sequence, you're going to see that each term differs by, some constant amount, like we've added 5 each time or subtract 5 from each time. The common difference you should think of as slope. Okay? Really works the same way as slope will. Because when I look at this, this explicit formula for an arithmetic sequence is really just the point slope equation for the line, just with some different values filled in. Let's do some examples here. So let's look at this sequence. Let's say we want to write the, we'll write the explicit and recursive formulas for that and then calculate some terms. Sound good? So the first thing that I'd want to look at is to see if this is an arithmetic sequence. So to do that, I'm going to look to go from 2 to 11. What would I have done? Added 9. 11 to 20, add 9. 20 to 29, 29 to 38, 38 to 47. I do need to make sure I'm checking between every single term, because I would not put it past some sneaky jerk like Mr. Kulik to have like the first 5 of them work and then the 6th one is like off by 1 or something and tricked you into thinking something was arithmetic when it wasn't. That feels like a trick Mr. Kulik would try to play on you to make sure you're paying attention. So what does that tell me right away? Tells me the sequence is arithmetic, and it tells me that the value for D is 9. The common difference is 9. So if I want to write my explicit formula, that's this, right? So if I fill in, my A sub 1 is the first term, and my D is 9. And then I'm just going to clean this up a little bit. Oh my goodness. That 9n turned into A sub n on me. 9's and A's. Everybody good with how we got the explicit formula? Let's say I wanted to also write the recursive formula. So the only thing I need to fill into the recursive formula is the value for D, but I also need to give one other thing when I give the recursive formula. I need to give it a starting point, right? Because if I want to find, if I want to find the next term, I need the previous term to do that, so I have to have an initial value somewhere along there. So in this case, we also need to list that the first term is 2. Everybody okay with that? So I have six terms here listed. If I asked you to compute the seventh term, I can just plug it into the explicit formula. Or if I was using the recursive formula, that would mean it would be the sixth term plus 9. And the sixth term we know is 47. Does everybody feel okay doing this? This should be relatively easy, right? And hopefully familiar. A slightly more challenging question. What if I ask for an explicit formula, but I don't give you consecutive terms? So here it says, I have the arithmetic sequence. It's really important that you read that and you're using the correct sequence formula.
You can plug it into the equation and go backwards.
Yeah, I would almost just think about it like as a linear function.
Yeah.
So the common difference is the same thing as your slope. So this is like the 0.15. This is like the 0.5 comma 11. Is everybody okay there? It's my common difference.
You can do that for all of them.
All arithmetic.
I've never done that. That seems so much simpler than the.
It is, isn't it?
Yeah, it is.
Right? Like this is,
I'm surprised I've never learned.
yeah, this is my preferred way of teaching this.
Yeah,
It's just like,
it's much better, yeah.
let's just take it back to basics here.
Yeah.
So a sub n, and now y1. I have 2 points. Does it matter which one I use as y1? Nope. Oops. And then my x1 would be here. So I just chose to use this as x1, y1. And then I just simplify things. So I have minus 3 over 2 plus 5 is going to be plus like 7 over 2. And I'm done, right? So again, you can use the explicit formula, and like what Lucas was describing will work. This is so simple though. Like this is just clean, and it just scaffolds right onto something we just got done doing. Like, why not do it this way? It'll work every single time for arithmetic. I would encourage you to do this, you know? Presuming that you remember things like the slope formula and the point slope equation for a line makes it really simple. It's like, oh, this is just what we just did. All right. So again, we can use a sequence to answer these kind of story problem situations. So it says, Susie decides to deposit an initial amount of $1,200 into a savings account on June 1st. The account pays 5% simple interest on the initial amount. Assuming no deposits or withdrawals, how much money after 10 years? The simple interest is kind of important here. What is the difference between simple interest and compound interest?
It's like it's a little things compound all the time.
So not quite. The basic difference here is that simple interest is always calculated from the initial deposit. Compound interest is calculated from the value of the bank account at the time. So essentially compound interest, you're earning interest on the interest from last year. In the next year, the simple interest, you're never doing that. You're always just earning the same amount of interest from that initial deposit. In the real world, simple interest doesn't exist. Okay. So my simple interest, let's calculate what that is. It's going to be 5% of 1,200. It's too early for me. So that's 60. So that simple interest is going to be the D, the common difference, because that's what's being paid on each year. So at year 0, we should have $1,200, and then each year subsequent to that, we should add in $60. So if I want to know the value of the account in 10 years, it's a really disappointing $1,800. The compound interest version of this would be quite a bit more. Does everybody feel okay with what I've done here? Again, fairly simple. I'm not doing much. Okay. So here we're given 3 terms of our sequence, the 50th term, the 51st term, and the 52nd term. And we're asked to find the first term. So the first thing I would want to do here is just check to make sure that I'm looking at an arithmetic sequence. So it looks like my common difference is 5. Does everybody feel okay there? So now I'm going to go ahead and write my explicit formula for the sequence. So again, I'm going to think about it like a point slope equation for a line. Where these guys are just like my points. Does everybody feel okay with what I'm doing so far? Y is just the same thing as A sub n. And then let's say this is x1 and y1. So just clean this up a little bit. Oops. Again, we use n's instead of x's. And that's going to be 256. Oh, no, it won't. There you go. 5, that's negative 250. So negative 244. Sorry. Yeah. Mental math at 8 o'clock in the morning. Do it at your hazard. So again, the question asked for the first term, a sub 1. Well, now that we have the explicit formula, I can find any term I want really easily. by just plugging the term number in, and I'm done. So even if it had asked for the third term, or the 96th term, or the 10,032 term, it doesn't matter. I have the explicit formula. I can generate any term you want from that. Does that feel good to you guys? So again, almost any of these questions, it's like, just give me the explicit formula, and then I can just solve equations, and easy peasy, lemon squeezy, right? The next special type of sequence we'll talk about is the geometric sequence. It has nothing to do with geometry. When you hear geometric sequence, you need to think exponential function. So they'll work the same way as an exponential function. So our recursive, or our explicit formula for a geometric sequence is the first term times r to the n minus 1. And the recursive is the previous term times r, where r is the common ratio. So that's like, you know, the 8th term divided by the 7th term. Or the 2nd term divided by the 1st term. They should all give you the same value when you take 2 consecutive terms and divide the later term by the earlier term. So let's take a look at an example here. So if I look at this, if I think, okay, what type of sequence do I have here? Well, maybe I think let's try arithmetic to start. So to go from 3 to negative 12, I'd subtract 15. But to go from negative 12 to 48, I have to add 60. And already I know it's not arithmetic, right? Well, maybe instead of adding and subtracting, we're going to be multiplying and dividing by some constant. That's the geometric situation. So to go from 3 to negative 12, I'd have to multiply by negative 4. To go from negative 12 to positive 48, again, I multiply by negative 4. Oh, I'm on to something here. To go from 48 to negative 192, I multiply by negative 4 again. And to go from negative 192 to 768, I again had to multiply by negative 4. Is everybody okay that I'm using the X there as a multiplication symbol? I don't want that to be confusing. Should I change it to a dot? Maybe I should. Now it looks like a X minus 4. I'll do that. Okay. So what have I just found here? Two things. I know it's geometric, and negative 4 is equal to r. So if I want the explicit formula, that's this one. So my first term is 3. My r is negative 4. And then there's that. Done. Woo! My explicit formula is the previous term times r. And just like with the arithmetic sequence, I need to also give a starting value. So I'm going to list the first term, which was 3. Is everybody good how I filled in things to my formula here? So similar type question, it says here we have the geometric sequence whose third term is 243 and its seventh term is 3. We want to write the explicit and recursive sequences. So R is not related to slope here. So I have to remember I'm dealing with a exponential function. So what I'm going to do here is I'm actually going to solve a system. So I'm going to think about this as like 3, 243, and this is 7, 3, where this is like an n, and that's like an a sub n. Is everybody okay there? So I'm going to plug this in. So I'm going to have 243 equals a sub 1 times r to the 3 minus 1. And I'll have 3 is equal to a sub 1 times r to the 7 minus 1. Is everybody okay with that? That's going to be like a system of 2 equations. Before I solve that system, though, I'm going to do a little bit of simplification and just subtract those exponents. And I'm going to name these 2 equations, equation A and equation B. Is everybody okay with what I've constructed so far? Now to solve this system, because my variables are multiplied together, to solve this system, if I'm doing elimination, I need to divide the 2 equations rather than adding and subtracting them. So my suggestion when you do this, to make your life as simple as possible, I want to take the equation with the bigger exponent. In this case, that's the 6, and divide it by the equation with the smaller exponent. So that is the 2. So we're going to do equation B divided by equation A. So when I do that, the left-hand side would be 3 divided by 243. And the right-hand side would be a to the a sub 1 times r to the 6th divided by a sub 1 times r to the 7th. Is everybody okay there? So 3 over 243, that reduces to 1 over 81. My a sub 1's cancel out, because a sub 1 divided by a sub 1 is just 1. And then r to the 6th divided by r to the 2nd. When I divide exponents, how do I simplify that? Subtract the exponent. So 6 minus 2 is 4. Everybody feel okay here? Okay. So then to solve this, I'm going to take the 4th root of both sides. Now, because it's an even root, technically speaking, I'm going to get a plus or minus here, which means I'm going to get 2 sets of possible answers. Oh no! It'll be fine. So if I take this value for r, I can now solve for a sub 1. I'm going to go ahead and plug that back into either location. It's fine. Now I want to point out to you that because both of these exponents are even, is it going to matter when I plug in negative 1/3 and positive 1/3? What's going to happen? I get positive 1/9 in both situations, so I'm okay. I'm not gonna have two, I don't have to really plug this in two separate times. So I multiply both sides by 9, and oh dear, Mr. Kulik doesn't remember that. 243 times 9, 2187. Everybody feel okay? So I have R, I have the first term. Does everybody feel okay with what I did there? Unfortunately, there's not like a linear algebra or a slope shortcut through this. You got to actually solve the system, but it's fine. Compound interest, you guys remember doing this in your previous pre-calculus and algebra 2 courses, I assume. So what I'm given here is the compound interest formula, where A is the account value at some time t, P is the principal, that's the initial investment, R is the interest rate as a decimal, N is the number of compounds per year, and T is time in years. So it says Sam puts $1,500 in the bank account. That's P, earning 6% annual interest. So my R would be 0.06. Compounded monthly. That means that the N is 12. And then how much will the account be worth in 20 years? That means T is 20. So I would say that A is equal to 1,000 times 1 plus 0.06 over 12 to the, that's NT, right? 12 times 20. Is everybody okay? Into my calculator she goes. And 49,653.07. That's got to be close-ish. Okay. So part B then asks how much interest was earned in that time. How do I figure that out? Not divide. Right, we're just going to take the amount, the future amount, and divide it by the initial. Everything else, the value accrued on that would have been from the interest. So that's like our 49,643.57 minus 15,000. So almost 35,000 bucks for just parking your money and ignoring it. I have $1,000 to invest and want that to double in 10 years. What interest rate do we need, assuming we're compounding quarterly? That's my P. So I want it to double. It tells me my future value needs to be 2,000. Equals 10. What interest rate means that R's are variable, and compounded quarterly tells me that 10 is 4. So if I fill this in, I have 2,000 equals 1,000 times 1 plus R over 4 to the 4 times 10. Everybody feel good? To solve for R, I'll begin by dividing both sides by 1,000. And then I'll take the 40th root of both sides. Now that's an even root, so technically I'm getting a plus or minus here. Why do I know I can ignore the minus? Because I want the bigger interest rate no matter what, right? Like subtracting is going to be silly. So we'll subtract the 1 over. And then multiply through by 4. And that should be my interest rate as a decimal. -4 plus 4 times 2 to the 1/40th. I'm going to write in my square root that way, or my 40th root that way. Is everybody okay? You could have also done math and then Command 5 and typed in the 40 manually. It's just a little clunkier to use. So just about 7%. Okay, do I have anything else on here? That looks like everything. I want to take a moment here and show you some calculator pieces that can be super helpful. Oops. Okay. Let's say we're doing this problem where I've given you 2 terms of an arithmetic sequence and asked you to write the formula. If it's me, and I'm taking the IB exam, I'm never doing this problem by hand. The calculator is going to do this for me entirely. What I will do is I'm going to enter these 2 points into a list. So I'm press stat. And then from the edit tab, I'm going to pick the edit command. Into L1, I'm going to type what would be the x coordinates, so 1 and then 5. Into L2, I'm going to type the y coordinates, so 5 and then 11. Okay. Exit out to the main screen. Then press stat again. Go to the calc tab. I'm going to take the linwrite command. I'm going to use L1 and L2 as my x and y lists. Not going to bother storing anything. I'm just going to press enter, and that tells me that my equation for the line is y equals 1.5x plus 3.5, which is the same thing as a sub n equals 1.5n plus 3.5. Calculator did it all for me. I just had to know how to ask it. Now, that's not a big deal because this one's fairly easy algebraically. Where it becomes real nice is a geometric one, because this was kind of a hassle, right? I can do the same thing. That's not what I want to do. This is what I want to do. So stat, edit. I'm going to type my x's, so 3 and 7 into L1. And type my y, so 243 and 3 into L2. Everybody's okay? Exit out of here to the home screen, stat, calc. And then this time, what type of function is a geometric sequence? Exponential, so I want exponential reg. There it is. Say, whoa, 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 Mr. Kulik. Whoa. That is not what you have there. Nope, it's not wrong. They're actually equivalent answers. The reasoning is that this is to the n. This one was to the n minus 1. So if I account for that, this one would need to be multiplied by 3, which is this value. So they are the same answer. The form looks a little bit different, but like, gee golly willikers, that was so sweet and easy. What do you guys think? I'm stopping here because we've just done, like, I think 3 sections of the textbook. And I don't think that anybody wants to do the whole chapter in one day again. We did that once. We'll do this in 2 days. So for your homework, well, let's think about this reasonably. What do I have written down? That's a lot. Let me look at the textbook. See if there's a better way of assigning this. Because it's a lot of the same thing over and over and over again. So here's what I think we'll do. Okay? Everybody feeling good? I'm not going to assign this, all these problems, as like 50-something problems of how they have parts A, B, and C, and it's kind of like a rather large load. I'm just going to wait until next time, and I'm going to assign the review. And we're just going to do the review for this chapter. It'll be the only homework assignment. But you can't really do it until we've done the next sections because they've mixed all the problems together. They're not like linearly. So there's like parts inside of the problem that require sequences and then some other parts that require series. So you can't really start it until we've done the whole thing. But I think we'd rather do that than like 100 problems.
You already did the whole one.
You already did it?
I did like half of it.
Oh, you got some extra practice.
Oh,
That sucks. What do you,
It's just gonna be better than you guys have test.
do you guys feel good with that plan now? If at any point you want extra practice, obviously you can do these, right? They're not points, it's quality work. Like if you feel kind of shaky about it, you're like, I don't know, this felt like the first time I'm seeing this because you say that I learned this before, but I don't remember anything. Would probably not be a terrible idea to kind of pick through that and do a little bit while you're waiting, but that's it for me. What is your I want to hear your opinion on this now. Would you rather do quiz next class and then the rest of chapter 3 and then the test? Or would you rather do the rest of chapter 3 quiz test? So think on that. I'll ask you again in like 15 minutes before we have to go. But think about whether you'd rather take the quiz sooner and potentially have it back before the test, or take them back to back.
No, we want to keep.
So it's like if you take it.
The next class.
I don't want to be doing
that.
We have to do it.
I think that's the smarter plan.
Best.
Okay. So the quiz would cover just the stuff we talked about today. Oops, not chapter, wrong chapter. Okay, so you should be able to, on the quiz, you should be able to identify sequences as arithmetic, geometric, or neither. Should be able to use an arithmetic sequence to do a currency exchange. From given information, find the nth term of a sequence and compute the value of a specified term. That's the quiz. Okay, rather straightforward, I think. So are we decided then? Are we quizzing next time?
Yeah.
Yeah, I think that's best. So that would be Friday for you guys. And then the following week we'll do the rest of chapter 3 and the test. Okay? Yeah. That being said, before the quiz, if you want to do some review stuff, what should you do? Look at those like 13.2 and 13.3 homeworks, right? Just pick some stuff. Almost anything will be a decent question to try. If it feels too complicated, just skip it, go to the next thing, right? If it's like, I don't even understand the situation they're describing, this is some convoluted story problem, you know, just be like, all right, well, that's, you know, you don't need to do it, just practice. Lucy, you've misbumped your chapter. Okay. As long as you don't mind looking like a fool, I don't mind you looking like one.
It's okay, I was like, oh, down there.
Okay. There you go.